Hello, and welcome to PreCalc 107. Sorry I couldn't be there today with you guys, but I hope you really enjoy this lesson because it is incredibly useful. Now today we're going to talk about the matrix. And I am not talking about the inappropriate movie from the 90s. No, instead, I am talking about ways to organize data. So, as you may or may not know, your computers, your cell phones, everything that you use that contains numbers usually stores them in table form. And we use matrix mathematics in order to compare data in table form, to solve equations. You can solve a system of 100 equations and 100 variables using matrices rather than using some of our slower methods like substitution and elimination. Can you imagine having to substitute 100 times? It's impossible. So it would actually be like 100 factorial times because then you have to go, horrible. But matrices are helpful. Now, you've already seen matrices in this class. What we've been doing is we've been finding the determinant, right? You go and, let's pick a small one. And I was going to do the big one, but I was like, nope. So, how do we find the determinant of a matrix? Well, we multiply down 1 times 5, and then we subtract whatever the product of the two numbers on the other diagonal are. A minus 4 times 2. That, as a review of our previous lesson, is -2. Now, what's the dead giveaway that it's one of the old problems and not one of the new problems that we're talking about today? If your matrix has these vertical lines, then they want you to find the determinant. This is the old stuff that we've been doing for weeks now, okay? But today's lesson, we're going to talk about a different way to use matrices, okay? And so the dead giveaway that you're working on one of today's problems, as opposed to the old problems where they want you to find the determinant of the matrix, which is just a friendly way to measure how good or well-behaved the numbers are. Yeah, no, I shouldn't say anything negative about students. That wouldn't be appropriate. Not good. You may be wondering why I'm talking about how well-behaved a matrix is. We'll get into that a little bit later once we start using them to solve systems of equations. But what we're going to talk about today is matrix addition and subtraction. We'll also talk about multiplication, and we will not talk about division because it makes no sense. So, when we talk about a matrix. So, let's talk about addition and subtraction first. Now, up to this point, you've seen square matrices, where the number of rows, those are the sideways ones, equals the number of columns. Columns hold up buildings, so they go up and down. But we're going to call the size of a matrix number of rows, and then we're going to put a little x there. It doesn't mean times. We just usually write it this way, by the number of columns. So the size of this matrix it has the size of 2 by 3. So this is a 2 by 3 matrix. Why? Because it has 2 rows and 3 columns. Now, the key to addition and subtraction is this. You must have the same size. Sorry, all you pen writers. You're going to have to fit that in there between my comments. So, in order to add matrices, they must be the same size. Otherwise, it won't work out. So let's add these two matrices. Now, what's the dead giveaway that you're on one of these problems and not one of the old ones? Because we will write our matrices with brackets instead of just the vertical lines. So you'll have to be on the lookout. If they're asking you to find the determinant, they'll use the vertical lines. If they're asking you to add, subtract, or multiply, they want you to use these, and you should not find the determinant. In fact, on this one, you can't because it's not square. Number of rows does not equal the number of columns. So let's get right to it. 7, 8, 9, 10, 11, 12. So each of these matrices has a number in each index or each spot. Think of it as a table, and if I put these little dotted lines here, you can see the spots of the table a little bit better. Now, the answer to your addition is going to be simple. It's going to be the exact same size as your original matrices. So if your original ones were 2 by 3, then your answer is going to be 2 rows by 3 columns. Then, now this is really like mind-blowing. Are you ready? For the number in the first spot of your matrix, just think of them as tables, okay? You're going to add the first number here to the first number here. 1 plus 7 is 8. For the one in the middle spot, we're going to take the 2 middle spots. 2 plus 8 is 10. Now, for the number in the upper right spot, 3 plus 9 is 12. 4 plus 10 is 14. 5 plus 11 is 16. And no surprise, 6 plus 12 is 18. So, this matrix is your answer. Okay? All it is a table. Okay? Think of your Google's sheet where you put in numbers for science. That's all it is. It's a table way of organizing data. But we don't draw the little lines. If you want to draw them in to help you out, you're more than welcome to do so. Subtraction is going to work the exact same way. So if I were to subtract 2 matrices, they still have to be the same size. And you're going to subtract each element from that spot. So I know my answer will also be a 2-row by 1 column matrix because it has to be the same size. Okay? How else would it work if I was adding all the same spots? If you have 2 matrices that are different sizes, you cannot add them. So it might be a dead giveaway that you're doing something else, like multiplying them or finding the determinant, because adding is not going to work. So here we have 1 minus 3. Adding and subtracting are basically the same operation, so we have no problem with this. 1 minus 3 is negative 2. 2 minus 4 is also negative 2, and that's your answer. Now, if that were all of this lesson, man, it would be a walk in the park. But you're in pre-calculus. We know things don't come that easily. I love how God gives us, or has allowed these systems to be in place to where these things just work. Like, I would never wake up in the morning and be like, how can I arrange data today? Oh, let's put it in a table. Oh, now let's add, subtract, and multiply these tables. It's crazy. But I will tell you that although addition and subtraction are great, and they are useful in computer science and in engineering applications, that's right, engineering, the most useful operation for matrices is multiplication. But it's also the hardest to wrap your head around. So I need you to really focus on this part of the lesson. Okay? There's 2 types of multiplication. The easy type of multiplication is basically addition all over again. If you have a number times any matrix, I love my 1, 2, 3, 4 matrix. If you have a number times any matrix, then you simply distribute that number to each element of the matrix. So this is going to become 1 times negative 2, 2 times negative 2, 3 times negative 2, and 4 times negative 2. The matrix will stay the exact same size because all you're doing is distributing. So the answer is negative 2, negative 4, negative 6, negative 8. So anytime there's simply a number in front, you distribute that number. But the actual, real, awesome use for matrices, again, this kind of leads to how you can solve systems of however many variables you want, like 100 variables in 100 equations. You can solve that using matrix multiplication. So, how do we do it? If we can get that to stick. Nope. There we go. Eraser wasn't cooperating today. Well, matrix multiplication first requires something special. It requires that the middle numbers of your sizes of the matrices match. Okay, that's a little weird. So, the number of columns of your first matrix has to equal the number of rows in your second matrix. Okay, again, right now we're just learning the skill. I'll show you how to apply it later, but for now, we're just stuck here. I'm sorry, this is what it is. But when we multiply matrices, the number of rows, or the number of columns in the first one has to equal the number of rows in the second one. So, it looks a little funky, but let's try it. So if we have this matrix, and I want to multiply it by this one. Okay? Let's look at the size of each matrix. That's going to be your first step. The size of this matrix is 3 rows by 1 column. The size of this matrix is 1 row by 3 columns. Okay? And so, this works out nicely because my requirement is met. The middle numbers are the same. Now, from there, what am I going to do? Well, it's actually really funky. I'm going to take this first number. And actually what I'm going to do, it's really weird. Okay, are you ready? I'm going to multiply this times that sideways. Are you ready for this? This is crazy. So I'm going to use blue here just so you can see it a little bit better. So I'm going to take this column and multiply it by that first row. Weird? Yeah, that's weird. So this is going to look like the following. We will end up, now here's what's really fun. I messed this up. The result of our matrix multiplication is actually going to be a 3 by 3 matrix because this is how it ends. Gross? Absolutely. Oh dear, I'm losing it. All right, we're going to have to do an example from the book because I don't want to go there yet. So, wow, it's over. That's it. We're done. Huh. No, you wish. All right, so let's try this one instead. Hopefully this will be a better example for you. 1, 2, 3, 4, 5, 6. Times this matrix. We have 7, 8, 9, -2. Okay, so again, first step, we're going to look at the size of the matrix. Sorry, I backstepped there a little bit. The number of rows here is 3. The number of columns is 2, because there's 2 vertical columns. Columns hold up buildings. Over here, we have a 2-row by 2-column matrix. What is our result going to be? Well, we're checking to make sure the middle numbers match. They do. So our result is going to be a 3-row, 2-column matrix. Okay, so I'm going to draw out a 3-row, 2-column matrix here. And in this case, just to help you visualize a little bit, I am going to put the little dotted lines so you know where I'm working. So it has 3 rows, 2 columns. Now here's where it gets a little tricky. We are going to take from the first row and multiply it by the first. Am I losing it? I've lost it. That's it. We've lost. Game over. Do I believe this? Yep. So I'm going to take this first row and multiply it by the first column. Rows? Yes. And so each time what you're going to do is you're going to multiply a row times a column. Oh. So this is going to be 1 times 7 plus 2 times 9. Now, how did I know it went into the first spot? Because it's the first row, so it goes in the first row, and it's the first column, so it goes in the first column. Now, we'll evaluate this in a second for our final answer, but let's keep going. So now I'm going to move on to this spot here. I'll use a different color. This spot is on this matrix in the first row, second column. So I'm going to take the first row of this one and the second column of this one and multiply it. So that is 1 times 8 plus 2 times negative 2. And the process will continue until all of these boxes are filled. So let's work on the next one. I'm done with the first row, so I'm done with 1, 2. Now I'm going to multiply 3, 4 times 7, 9. 3 times 7 plus 4 times 9. You're multiplying the individual elements. This is so important because it actually helps you do all sorts of incredible things. But you just have to get into the process of it a little bit. So now I'm going to take this row and multiply by this column. 3 times 8 is 20. Well, 3 times 8, and 4 times negative 2. Okay? It will always be row times column. So, my last row, and what's cool is that you know which one to choose because of which row and which column you're in your answer. So, just in case you missed it, I made my answer 3 rows and 2 columns because those are the leftover numbers from the size of my matrix. Okay, so this is row 3, this is column 1. So I'm going to take row 3 and multiply by column 1. 5 times 7 plus 6 times 9. Then I'm in row 3, column 2, so I'm going to multiply the third row times the second column. 5 times 8 plus 6 times negative 2. Now I can evaluate each of these little boxes. 7 plus 18 is 25. 8 minus 4 is 4. 21 plus 36 is 57. 24 minus 8 is 16. Trying to do math in my head without looking foolish. 35 plus 54 is 89. And our last one, 40 minus 12 is 38. 28. Wow. There we go. And that's our answer. Again, this is a skill that is so important. But you'll probably only learn it by practice. So let's get to that practice now and enjoy problem set 108.